a couple of quick introductions on the AET side. And if you do, I think what we'll do for this meeting today is if you do want to talk a little bit about yourself or share where you're from, we will have a portion towards the end of our session, which is just an hour, where we're inviting all participants to jump in, share a little bit about your own classroom projects if you like, or of course, questions. Questions are big. So any questions you might have, please speak up. The chat is also open, so that can be used, which I'm typing in right now. And typically, Kristen will chime in and help with fielding chat questions. So again, hello, my name's Adam Zelny. I'm the application specialist with AET Labs. And if you're new to AET Labs in general or learning about us, I'll let one of our other participants just give a quick introduction and talk about that. Kristen and Dave, or Kristen next, do you want to introduce yourself?
Hi everyone, I'm Kristen. I work in marketing, so I work with Adam in running these. Again, like Adam said and Dave said, if you ever have any feedback, topic ideas, you want to co-host with us, let us know. We're happy to have you. And one frequently asked question that we usually get is, will you get a recording, a copy of the recording? And yes, you will. You'll get an email tomorrow with this recording.
Dave?
Yeah, Dave Kempsky, principal founder of AET Labs. And we're doing the kind of thing that I always dreamed that we'd be doing someday, and that is providing resources to you guys and doing helpful things like this. So that's exactly what I want to make sure. I want to make sure it's helpful. I want to make sure that that it is providing value to you guys. We don't just sell equipment. That is how we survive. We make our living that way. But we feel that one of the biggest things we can do today is to be helpful to you guys. So we really hope that you share what your needs are with us and provide feedback on these types of events. So thanks for joining us.
Thanks, Dave. We also have a few of our sales consultants with us too. And if any of you gentlemen would like to do an introduction. Matt, would you like to?
Love to. I'm Matt. I cover Eastern Mass, Rhode Island, New Hampshire, and Maine. Both the university, but some high school accounts scattered in as well.
Chris?
I'm Chris Macrina, newest member, been here about 2.5 weeks or so, and call mostly on CTE schools in the Eastern Mass, Rhode Island, New Hampshire, and Maine locations. So at some point, I'm hoping to get to know some of you guys that are in the CTE world.
Thanks, Chris. And I think we got a couple of others, but I can't see the full list right now. But if
Adam, I'll jump in quickly. It's Justin Tursky from AET. I cover Connecticut, Western Mass, and Vermont. I'm currently actually on the road driving back to my office, so I'm off camera right now, but hopefully I could jump on camera in a little while. So look forward to working with you guys. Thanks for joining us today.
Thanks, Justin.
And one quick thing for those of you guys wondering where Mark Lyons is, because I know a lot of you guys know Mark Lyons. He is still around. He's focusing on some other things these days, but he's still around with us. So.
All right, so I'm going to jump right in here. Quick outline of our setup. We usually start off with either myself or a co-host where we've been starting to integrate teachers from schools that we work with into these Tech Tuesday events, which have been wonderful. And sometimes they'll come in and be a guest presenter. If that's ever something you would be interested in doing, you can absolutely get in touch with us. And I will provide later in the meeting, I'll provide a link to my email, and you can reach out to myself and Kristen regarding that. So I'm going to go over a little presentation here, and I love doing these Tech Tuesdays in a conversational fashion. Sometimes I may cap if we start launching or going off into a trajectory that diverges and say, I got to just wrap this up. But I do like to leave a chunk of time for you wonderful teachers to share a little bit, ask some questions. The goal of my presentation today is really to talk about using the laser cutter with students in classroom projects, makerspace projects. This can be curriculum oriented, after school oriented, community center oriented, wherever you're working, whomever you're working with. And specifically, I use Fusion 360 to design content, and I love working with the parametric workflow. So that is what I'm going to focus on today. You can see right now in our main slide, we have an adjustable phone stand, and this is one of the simple projects that I started with, but it can get complicated very quickly. And I say that in a good way, because we want these students to start off with something fundamentally easy, but be able to launch off into something complex that branches out in the CAD and digital fabrication world. So bearing that in mind, I invite you to, if you have any questions, jump on in. You can type into the chat box if you'd like, or just unmute yourself if you'd like to ask directly. And of course, in general, web meeting etiquette, make sure you mute yourself after you're done talking. So let's start off with, stop presenting this. And the first thing I want to do is I want to show you a couple of photos of end products. And that will be, let's see if you all can see this okay. All right, right now, you should all see just one of my web folders here with a bunch of photos. If anyone can't see it, please let me know. I'm just going to share a couple of end results of projects I've worked on, both personally and in the classroom environment. This is one of my earlier laser cutter projects, and this one actually wasn't done with really any knowledge of parametric modeling. I hadn't learned too much about it at the time. I was just getting into it, but really neat project to work on. And what I love about our topic, structural design, structural being the key word, is that our goal is to use this, this machining platform, this laser cutter machining platform, to cut flat sheets of stock, and then figure out what's the most efficient or best way to assemble them to meet our end goal. In this case, I made this internal drawer that slides right in and kind of just holds itself in place just based on the proximity to the drawer house to the inner wall, and it works great. I ended up auctioning this off. This is actually a prototype, but there's a nicer version. I ended up auctioning off at an art show. And let's pop back here. This is something I want to dig into at a later Tech Tuesday date, but the pieces are 3D printed. It just lends itself to a really great workflow to incorporate 3D printing into a project like this. Here's a really cool makerspace project that some members did together. So this is all laser cut cardboard. And each of these pieces, the designer of this essentially numbered every single piece and gave instructions in order to assemble it into this 3D shark. Really, really cool project. Here we have a hinged box. This is just a kind of a raw version of it, but this is something that I've actually done with teens in a workshop and adults. And one thing that I definitely stole from someone else's design is this really wonderful bearing design in the sides of the box in order to open the lid. Really cool, clever way to stick to just use, having everything laser cut. So furniture, load-bearing furniture is something that I want to talk about today, and that's an example of this right here. I actually have this, or a version of this, in my home office that just sits against the wall and holds some stuff like books and instruments and so on. And here are some folks in a workshop that I did at a makerspace in Worcester assembling this piece. Okay, this is, oh yeah, let me see. If you're new to laser cutting or laser engraving, and you might just often see glass or wood or maybe acrylic, but what we may not see a lot of is leather. And this is just an example of how beautiful laser engraving looks on leather. And you can see by contrast, there's to the right of it, there's a rough engraving, but leather and fabric in general is something that I don't see a lot of people doing, but the laser is ripe for incorporating into like clothing design and fabric, jewelry like earrings. And this was actually produced by a student, an adult who I worked with in a makerspace, who I taught a workshop specifically about like laser cutting small pieces of wood for something like earrings. And she went off and made her own Etsy store, which was really neat. Great thing to pitch for student project ideas. Absolutely. Like the earring one is wonderful because it's just like, there's so many options. Here's the phone stand you saw earlier. This is just scrap clear acrylic that it was laser cut with, but acrylic cuts so beautifully on a laser. It's other than the fact that it smells pretty bad, it machines really, really well. And it is a great material to work with on the laser. And here's another view. Let's see here. This is I just have a couple more images to show you. Let's see if I can zoom in on this. So this is just a prototype of a bigger project I'd worked on with a couple of folks. We were making a LED screen, kind of like an artistic installation, but the whole housing for the project is laser cut. And one thing that I haven't talked to many teachers about, but is are you using laser cutters more than just for engraving stuff, making structural things? In this case, you could make a jig for something. And I really was excited to show you this because this is a jig I made to bend a piece of acrylic, and my goal was to heat the acrylic so it would hold the bend. It did not work well, but still it was a pretty neat idea to begin with. I had never done anything like that before, but all the same, I want to show you this because it didn't occur to me until this time. I was like, oh geez, could I like do something to bend this acrylic? I could quickly design something to laser cut that would hold the form. So that's kind of thinking outside the box with the laser, which I like. Here we have some stuff that is kind of pulled from Epilogue Laser's website and some other content from other users, but this, if you really kind of get into the engraving workflow, the laser is, especially Epilogue lasers are geared for this, but lasers are capable of doing 3D engraving. And if you are interested in, I might not touch on that much today, but if you're interested in talking about that a little more, it's a really interesting process, so we can definitely do that. And here's another 3D engraving. Those of you who've used or have seen rotary devices on CNC machines, it's really a great tool for the laser. And we have these Epilogue machines that we package with the rotary tools a lot, and it's fantastic. students, they're very easy to use. It's plug and play, and I think students take off with projects. Is, you know, as simple as starting with like engraving the school logo on a glass or a water bottle, to developing their own logos or designs for like community events or personal use. And the last one I have some other stuff here, but the last one I have is just a kind of 3D rendering of a topographical map. And this is an interesting process where you can kind of separate data by color, like graphical data. So if you have a topographical map that is rendered in grayscale, you could essentially pull out all of the profiles of each level of the map, and that could transfer over to a bunch of separate profiles in the laser, where you can cut all these shapes that eventually will stack up to create the 3D topography. I'm going to switch gears right now. So does anyone have any questions? All right. Okay, so the next thing I'm going to jump into is the software side. Now, when we work with lasers, a lot of folks are, you know what, I should actually just open this some software for you here. But a lot of folks are working with 2D CAD, and that is kind of your default workflow to get to the laser cutter software. You start with 2D CAD, and you send your 2D document over to the laser, and you set your profiles, and you go ahead and oh, looks like we do have a couple questions. All right, hold on one sec. I got to turn my phone to silent mode. Kristen, can you see those questions?
Yeah, from Frank. There he is, he just waved. He's curious about the material vendor suggestions.
Oh, material vendor suggestions? Yeah. Materials, so I do have a link to Epilog's website, and I know that Epilog, when they ship their lasers, they give you a plethora of vendor samples. So yeah, we might have to tap into their website and see if we can find anything.
So yeah, so other people are chiming in. So David said Amazon.
Yep.
Tony's saying Highland Hardwoods.
Oh, cool. Highland Hardwoods. Where is that?
Johnson Plastics. Jay Freeman. That's what we have so far.
Cool. Great. Thanks, guys. So, all right, let me do a share here. Okay, so our typical onboarding workflow with the laser is using some sort of vector-based 2D CAD software. In this case, I have Inkscape open, where we might do something like create a shape, and we might go to Google and look up an image. And we might do something like this, and of course I'm doing this very just minimally and simply, but we might send something like this over to the laser, where we can just start off by talking about like rastering, which is, you know, if you're not familiar with the laser terminology, a raster is the laser's interpretation of pixelated art. So this would be pixelated art here. You can see that it's blurry as we zoom in, versus vector art, and vector art being geometry, lines connecting points. If we zoom in, nothing changes. It doesn't get pixelated because it's just paths. It's like essentially representing a tool path the laser will move on. And it's a great way to get started. And you can even do 3D design. You can absolutely, like, if you have the capacity to kind of like plan ahead and have that strong visual thinking, you can absolutely lay out, you know, you can put slots in this shape right here and have things connecting to this shape that you create in another area of your document. But if we really want to take advantage of structural design, we can switch over to our CAD software, something like Fusion 360. And what I'm going to show you here is a very, I don't want to say simple, because I've worked with people before who struggled to get the concept at first. So I don't want to kind of short sell that. I think that despite the fact that our students and our student population can be on electronic devices a lot of the time, this does boil down to some thinking that they may not be used to. So right now, I mean, it looks not necessarily appealing. It depends on what type of person you are, I guess. If you're like really excited about having a miniature table, which is like 20 centimeters wide or something, then that's great. But the purpose of this is to onboard somebody brand new to parametric modeling to A, the principle of it, and B, the laser workflow. And you know what I should do before I kind of show this off is I want to show you just one other slide here.
Adam, when you get a chance to, there's a question about how any ideas you have for introducing kerf to students.
Sure, yeah, absolutely. A saw blade, like a hand saw, that would be a great way to introduce kerf to students. So if you have like a miter saw, a miter box, or a saw with a miter box, or even like a safety saw of some sort, depends on what classroom environment you're in, but having them hand saw a material like a piece of pine or something, and talk about the fact that they just completely made sawdust and removed a portion of that material is a great way to start. That's a nice kind of clean, easy way that doesn't involve CAD to talk about kerf. And that's great that that's brought up, because my whole my next thing was just to bring this slide up, and this is, Kristen, this is up, right, the slide. Yep.
Yeah.
Great. So yeah, before we launch in, the central question is, what is parametric design, and why is it well suited for digital fabrication? And I just made a couple of points here. I'm not big on going like packing content into slides, just because I want to engage in a little bit of show and tell and discussion. But the 2 points here are CAD sketches and models are created using variable dimensions that can change relative to one another. That's essentially what parametric modeling boils down to. And the second would be dimensions can be quickly adjusted with respect to the size of the material being machined and the kerf of the cutting tool. So you're going to be working with different sheets of stock, right? And your stock is never going to be consistent. You'll have a piece of plywood or a piece of acrylic or cardboard. Cardboard's pretty consistent probably, but plywood specifically, you'll find a lot of different widths, and your artwork may need to be updated for that, especially in structural design. So let's pop back over to Fusion. And what we're looking at here is at current state, it's a 3-component assembly. And this assembly consists of 2 sides and a shelf. And you can see that these are assembled by tab and slot joints. And joinery, one thing I love about structural design with laser cutting is it really lends itself to talking about woodworking. So especially if you have students that were taking a woodworking class or are interested in woodworking, you get to talk about joinery and joints and how things fit together structurally. But we have some constraints when it comes to digital fabrication, because we're working with flat stock. So we can only get away with a certain type of joints. Tab and slot is really common, and mortise and tenon is another type. So let's dissect this a little bit here. If you're not familiar with Fusion and you are questioning your current 3D CAD platform, this is one thing I love about Fusion. I think a lot of other CAD has this, but is this timeline down here. So I can slide this all the way back and kind of show you what this project looked like at the beginning. And this was it. That was my start right there. So this is the just a side profile with a dimension, in this case, a parameter. And this parameter's depth, and this parameter is thickness, which is a big one, right? So let me pop this back up. All right, so right here, we're working with something like, 1/4 inch or a little bit less than 1/4 inch plywood. But if I'm doing a joint, I need to make sure I know that the thickness of this slot right here is going to accommodate for, a slot, tab and slot joint. So what I do is when I'm creating my sketches, I'm trying to remember where I actually did this sketch. Oh, I think it was the shelf itself. So when I created the sketch for the shelf, I assigned parameters to the sketch with respect to the tab, kind of the length of the tab here, but equally important would be the thickness of the extrusion. And in this case, if we look at the extrusion, we can see that my variable is actually titled thickness. Now, at the heart of parametric modeling are parameters. And these parameters are often what we start with. Whenever I start with my designs, I do a sketch first, and I kind of visualize in space with like a ruler or a tape measure or calipers at my desk, and I say, what do I want this to look like? Just a rough idea. Because in parametric design, we can change this to be any size, or just about any size we want, within some limitations. So I make a variable called height, width, depth, thickness, and I add values or expressions to each one. And one thing that I love, and I don't want to get ahead of myself here, but one thing I love about parametric modeling is math is inherent. So those students who hate math, those students who struggle with math or can't do worksheets, this is, I want to hear from you, I think, but this is where we can tap in and get them excited about math. Because when we actually apply math to parametric modeling and see changes happen right before our eyes, it's wonderful. I hated math in school. And when I got into parametric modeling, I became a nerd about it. It was great. So yep, so here are some values here. This thickness right here, 0.512 centimeters. So that's a caliper measurement for my plywood. So I use digital calipers and measure the thickness of the plywood and add that. Of course, it doesn't have to be that. You could start off with something kind of rudimentary, just like just 0.5 or 0.4. And because I have that value attributed to the extrusion, if I change it right here in my my parameter spreadsheet to something like 0.75, you can see the shelf panel gets bigger. Not only does the shelf panel get bigger, but everything else updates as well. So I have two sides. Oops. that have slots in them, right? And actually, I could just take this apart so you can see it like this. And when I go into my parameters and change my thickness to, I'm going to do 1, you can see the slots adjust, the tabs adjust, and if my stock is, if I've done an accurate measurement of my stock and I understand a little bit more about kerf of a laser cutter, then I will machine this and or go to the next steps to machine it and have a really cool project that I can assemble. The next thing I would do from here is like, because at this point I wonder where the students are at, or I wonder where your heads are at right now. Do we ask the next question, like, is this structurally sound? And what's the answer to that? What would you change? How would you change it? What would your students say? And I'd like to invite you right now, if anyone would like to speak up on this, like, what's the next step from this? Do you have any ideas right now? Where would you take this in your classroom? What would your students do with this? Would they be bored by it? Would they kind of take off in like, imaginative ways? All right, it looks like we have some stuff here. Oh, that's from 30. Would someone be able to assist, this is Casey, assist in taking Revit blueprints and cutting them on the Epilog Zing? I think you'd need to share the file with me, Casey, in order for me to dig into it a little bit more. And again, I can add a link to my email so you can get in touch with me that way. Tony says, do you measure whatever you are using with a digital caliper to be as accurate as possible? You gave a thumbs up because I already talked about it. But yeah, digital calipers, absolutely.
Adam,
yes.
To answer your question, so Kobe commented, I think my students would then wonder about customizing, adding etching to the top or cutout for a handle.
Yeah, great. So yeah, so the next thing I would do from here, I just want to kind of take you on the workflow at this point. Once you've completed your CAD, and I do want to point out that because I have the height, width, depth, and thickness parameters attributed to a lot of this model, it doesn't just change with the thickness. My height will change if I go to 20 centimeters, then my structure will get taller. Or if I change my width, it can get longer. If I change my depth, I can really, it becomes a completely different thing. It's like at this point, it's bordering on a coffee table. And I'll also point out that you may have noticed that the slot also changes. So the slot changed in size. And if you're not too familiar with parametric modeling, this is a great way to start. It's just with a simple division equation in order to do that. And I want to show you that right before I jump into the next thing. And that equation is detailed in the shelf sketch, because the shelf really, it's responsible. So the shelf has two roles. It has the tabs. The shelf sketch has the tabs, but also the shelf itself, the three-dimensional model of the shelf, was used as a subtraction piece to remove the slot from the sides. So in my CAD software, whenever I change the shelf, that subtraction piece, this slot right here, is also going to change because I use the shelf to make that hole. All right, so let's take a look at this sketch. All right, I popped this up earlier, but we'll take a closer look. Notice I have FX before almost every single measurement here, and that's just representing a parameter. That's reminding me that, hey, you assigned a parameter to this. Like, so for example, this front to back measurement is, if I hover over it, is depth. I know that it's very small for you to see. Maybe I could do that So the magic where the tab elongates based on my depth dimension. If we look at our variable, now I could have made this variable here. I could have made the actual slot a variable, but I ended up doing the spacing between the edge and the inner edge of the slot. And this variable is depth divided by 5. So whatever I do and whatever I change with depth is going to update this dimension right here to be depth divided by 5. All right. In this case, it's 2. It's just 2 centimeters. All right, so that's like a kind of a quick intro on how you can bring in your first kind of math equation to alter the dimensions of your model. And I think if I'm not mistaken, I think that's all I did as far as actually having an equation. That's the only parameter that has an equation. And what's neat in Fusion is all of this stuff gets captured in like kind of the spreadsheet here. So if I zoom in, you already saw these dimensions here, but down here I have model parameters that are captured if I enter them, somewhere else on the model. And in this case, in shelf, I have all these things in the sketch that I added with depth, but here's depth divided by 5, which happens, I think, 4 times. If this isn't clear, I haven't been clear on that process, and anyone wants me to kind of reiterate, I can definitely do that. But that's just scraping the surface. If you really enjoy incorporating math into your designs, this can go in a crazy direction. And I have another example that I'll show you later.
Adam,
Okay.
we have some chat, if this is a good time.
Yeah, go ahead.
Okay. So just went to your question around like, how would you approach this project? So Tony had suggested building a prototype out of something like cardboard and going to wood and then building actual size, talking about and using that as an opportunity to talk about different materials.
Sure. Yeah, I mean, there's nothing wrong with that. I think that cardboard's a good scrap material to start with. You have to be really gentle with it because, if you start crushing it, then it kind of becomes useless. But yeah, you can cut it on the laser very easily, and it certainly has structural integrity. So why not?
Frank has a question that either you or anyone else could chime in around how much time do you spend personalizing the work? Because students would want to add details like raster images and names. Yeah,
well, I think this might differ school to school, but I think that there are a couple of ways you could go. You could set aside a class or even after school time for students to work on specifically the design side, or if you have any connection with graphic arts instructors in your school, that's a great place to start the conversation and say, hey, my students are looking to do these ornate engravings on their projects. Are you doing vector art with them? Is there any way that this could translate over to our laser cutter workflow? And if anyone wants to have a further conversation about that, I'm always eager to hear about interdepartmental work happening at schools. I know it's challenging, but when it happens, it's really exciting, and I think the students get a lot out of it. So, and I do see David's asking for this kind of process, is there anything that is not in the free version of Fusion 360? Fusion has changed over the years. The biggest limitation I've seen is in CNC toolpaths, but to my understanding, we don't have any limitations for the laser workflow, which is my next step here. So let's take a look at that. Okay, so so again, we have a fully parametric shelf that I have variables assigned to. At this point, what I'm going to do is I'm going to right click on any face of a finished model, a finished body, and I'm going to click Create Sketch and Finish Sketch. And then I'll hover on the shelf top and right click and Create Sketch and Finish Sketch. And what this does is it captures the kind of live face, or the variable, if you will, variable face of this 3D component. And if I look at my sketches, if I hide everything here and just look at my sketches, you can see there are now two very, very light sketch profiles. Now, the beauty about this, and again, I don't know if it works like this in other software, but I say it's like a variable sketch because if I go in and change my parameters right now, and I change, let's say, my thickness to 1, you can see that my sketch is updated based on the 3D, what's changed in the 3D model. And this is kind of, this is our last step, because at this point we have a variable sketch that we can change on the fly. And if this sketch matches our stock size, we can go and right click on our sketch, save as DXF, and we'll do side. Save as DXF for the shelf. And pull up our CAD software. And import shelf and side. Oh, I might only be able to do one at a time here. All right, and okay, and what we're seeing here is probably not an accurate dimension, because you need to make sure that your 2D CAD and 3D, or your 2D CAD is reading the unit measurement that you have in your 3D CAD. So for example, Fusion, I'm using centimeter measurement, and I would need to make sure my import is also in centimeters. In this case, it's probably not. But the ratio is correct, and you can basically see, what's needed here. So there's the shelf. Here is the side that I can just duplicate because it's symmetrical. And now I can do what's called nesting. And nesting is, if you're not familiar with it, is laying your parts out in the most efficient way to maximize use of stock on a laser. So if we have, I'm going to draw, let's say, I'm going to draw a square here. So let's say this represents our, I should make all this kind of dark. So let's say this big rectangle represents our stock, and this is our cut. This is a great problem-solving challenge for the students too, and to say like, okay, what's going to be optimal here? Some of them, I think a lot of bright kids will get this like right away, but with laser cutting, you can really maximize efficiency by sharing lines. So you could say, you know, really have everything touching like this. And then, you know, from here, if like your students are familiar with like, and again, this is stuff that happens in like a graphic design class, but are familiar with editing vector art, they can do stuff like, let's see if I can, they can do stuff like remove a piece of geometry. Oh, let me find this. Oops. Sorry, bear with me here. So essentially remove a piece of geometry between two nodes. So we have a node here and a node there. There we go. And right now, if I really was like kind of looking to, let's say I'm using a really expensive piece of stock and that this is really important, we could do something like this. And we could use the toolpath from this piece to also share the cut with this piece. All right, if that makes sense to you. And from here, yeah, we're sending it over to the epilogue job manager, and you know, doing our cut. All right, someone asks, is this Frank? Yep. Do you also suggest introducing layout? I find that some kiddos like to cut directly out of the center of a board, creating a bunch of waste. Oh yeah, so we're just talking about that right now. Yep. Yeah, so yeah, here we would yeah, we would position this up into the corner. And you know, Tony talked about cardboard. Start with cardboard. Start your students with cardboard. What a great way to make use of the kitchen's cardboard waste at your school. And it's kind of a cool thing to like walk up to your kitchen staff, right, and say like, so where students have been doing a lot of laser cutting, could you maybe put some really nice cardboard aside for us? Yeah. So yeah, that's kind of just like the quick workflow on that side. Let's see, we're at 1:50. You know, we only have like 10 minutes left, so I'd like to open the floor to discussion. I want to invite anybody to share some of the stuff that they've worked on, if you'd like. I always over prepare for these things because I could, you know, if you noticed in Fusion, I have like a bunch of projects prepared to show you, but you know, it's just there's never enough time. But it opens the door for more discussion or another meeting. So, and bearing that in mind, actually, I should share my email too. Oh, actually, I don't need to do this. I'm just going to pop my email, mine and Kristen's email in the chat.
Adam, I did it at the beginning.
Oh, you did? But
Yeah.
Both of ours.
Yeah.
What am I doing over here? Okay. While you guys, some of you are typing right now, while you're doing that, you know what I kind of specifically withheld from the shelf design here. Was, let me switch this parameter back to like 0.5. Was gussets. And gussets are an important structural thing for a lot of standing designs. All right, here are gussets that use two tab and slot fixtures.
Adam, we can't see your screen.
Oh, I'm sorry about that. Thank you. Yep. So here's the model with gussets. And these gussets also have, they're situated over here as a component, and the sketch for the gusset has a bunch of variables. So I have, oh, see, you can see here, you can see I actually, I put a measurement on the tab itself, and it is width divided by 6. I have a static angle of 45 degrees to the gusset. That won't change. That'll always stay at 45 degrees. And then I have a length, or width of the gusset, I should say, to be width divided by 2.8. And I think I did this just kind of like off the shoulder, off the cuff, just being like, okay, what might be the best size? So when I update the gusset, or I'm sorry, when I update something like the height, the gusset won't change, which I could do. I absolutely could create parameters in order for the angle to change, so it would slope down at a steeper angle and maintain this width. But if I do change width here, see the gusset actually does adjust to become bigger, increasing the stability of the structure. Gussets are pretty cool. Oh, thanks, Dave. Yeah, Dave included in the text a resource for laser cut boxes, and I do have, you know, I had other stuff I wanted to show off here, but one of them was creating finger joints is a big one with laser cutters, and the math that goes into producing parametric finger joints is bonkers. It's so much fun and kind of a headache at first, but once you figure it out, it's really, really, really neat. And you know, we got a couple minutes left. I may as well just bring it up.
Adam, yeah, one question related to that. Have you been able to find any macros to make finger joints?
I guess I'm not sure what you mean by macros in this context.
Whatever the Fusion equivalent is to a pre-recorded set of routines. Like in Onshape, there is a finger joint. They just call it feature script.
Gotcha. It's a script that's written, right?
Yeah.
For Fusion, that's a great question, like an add-on. Yeah, so in Fusion, they're called add-ons, right? Yeah. I haven't seen anything. And this is Todd who's talking?
Yes.
Yeah, okay.
Yep.
Yeah, Todd, I haven't seen anything, but quite honestly, I don't know if I've looked too hard. You know where I have looked up finger joint add-ins is on Inkscape. So the 2D CAD that we were just looking at, and they actually have like a layout, so it'll just kind of lay it out in, you know, on the flat surface. And but I can't. It's not, you know, it's not as smooth as doing it in a custom way on in Fusion. And oh no, of course it's not here. But yeah, let me just pull mine up here. There we go. Okay. Yeah, this is neat. So this right here, here are my parameters: height, width, depth, thickness, finger amount height, finger amount width, finger amount depth. And these are numerical values as opposed to measurement values. Unit values. And with a little bit of, and I should also show you probably down. Yeah, so here's some of the math that's happening in here. This one right here. It looks like space distribution, negative height divided by finger amount height plus 0.5. So that sort of stuff comes into play. And when you, I mean, for me, when I figured that out, it was like a celebration. But what I love about this is here you can set your optimal finger numbers. So right now I have finger amount height 12. I can switch this to 6, and it beefs up the fingers. So now they are a little bit more, they're thicker or longer, I should say. Same thing with the width. I could say 6. And you can see on the bottom, it just updates. For the depth, if I do 1, I haven't tried this, but yeah, look at that, 1, perfect. Yeah, so this is great. And another thing about this one that's really interesting is, I don't think I've done the math for this, but if I do, let's see, if I change height to 40, yeah, so this one will elongate the dimension of the fingers, just like that last one. And it preserves the finger numbers. So if you wanted to do something like change the height, width, depth, and you would have to also update the finger amount. Pretty cool though, I gotta say. What's great about this is once you have that math locked in, you can just kind of, how to apply it and where to apply it. You can have this kind of default file ready to go. So there's that. All right, folks. Well, I did a lot of talking. Again, I'll invite you to get in touch with myself and/or Kristen if you would be interested in co-hosting. We would love it. We've actually started co-hosting last school year, and we've had a guest from MIT. We have a guest, upcoming guest from Uxbridge High School, and we're looking for more. We're looking to, kind of spotlight you folks and see what you're up to. All right. So we'll close out the meeting, and I really appreciate everyone showing up. Thank you so much. Kristen, as always, thanks for your help.
Thank
Tony,
you,
good to see you. I'll see you Thursday, I think.
Yep.
All right.
Thank you. Thanks a lot, guys.
Okay, bye-bye, everyone.